Let us now turn our attention to understanding why A-B tests help in making causal inference. Now, the big idea out here is that when we do A-B tests, we generate new data to be used in the regression analysis. Okay, the regression specification does not change. It is exactly the same specification that we were using before when we were using observational data. But this time, when we use the data generated from the A-B test, then we have no problems in getting the correct causal inference from an X variable on the Y variable, right? So why does this happen? The reason this happens is that subjects in the treatment and the control groups in the A-B test, they are selected randomly. And therefore, any missing common cause variable occurs equally in both the groups. In other words, both the groups are balanced in terms of any variable, right? Because of this random nature or the randomness which is used in selecting the two groups, right? There is no preference in creating one group over the other group, right? In absence of any kind of preference, both groups are equally balanced in all aspects, right? So let's understand this using the example that we have already discussed. So this example was about that on a platform, the advertisers receive more clicks than non-advertisers, right? But then we identified that brand strength of the advertisers could be a missing common cause variable. Now, instead of using observational data, right, let us say that we implement an A-B test. When we implement an A-B test, then advertisers do not choose themselves to advertise or not advertise. Rather, the platform who is implementing the A-B test, the platform creates a treatment group of companies and gives them free advertising, right? And it also creates a control group of companies who are not allowed to advertise in the period of the test, right? So now you have got these two groups of companies that are randomly selected. And because they are randomly selected, the brand strength variable that we said was higher for companies who chose to advertise, now that problem is gone. Because of random selection, now the brand strength of the companies in the treatment group as well as in the control group is equal on an average, right? And hence, the brand strength variable is now uncorrelated with the choice to advertise, which was the problem before in observational data. And now, when we have A-B test data, then this problem goes away, right? And while we discussed this example of brand strength, imagine any X variable that was a missing common cause variable, right? The same logic that we have discussed right now would apply, right? Just because of the fact that the treatment and the control group are balanced on all variables that you can think of. And these variables can be, known, or these variables can be some unknown variables that, have not been imagined, right? But still, because of the random selection in creating these groups, both of these groups are equally balanced on all such variables, and therefore all such variables are uncorrelated with the advertised dummy. Therefore, in the A-B test data, these variables are no longer missing common cause variables. And hence, now the coefficient of the advertised dummy in this case turns out to be correct without any bias. So this is why A-B tests work. Let us now move on to the design of experiments. And in talking about the design, we will talk about certain principles to keep in mind, and then we will give several examples of situations where experiments were designed. And these examples will give ideas about how experiment design actually contributes in this area of web analytics, right? So keep in mind that if you want to figure out the impact of any kind of treatment, okay, or any kind of, let us say, a treatment here is a managerial decision, right? If you want to figure out an impact of such a decision, you should have two groups, the treatment and the control group. And the treatment and the control group should be randomly selected, right? Sometimes you may think that why should we have two groups? Why can't we look at the behavior of one group before giving them the treatment, and then how the behavior of this group changes after giving them the treatment? For example, you may think of that here is my group of customers and I did not expose them to any advertising before. And I have data about what is their average purchase behavior in that period. And then I expose them to advertising, and I expose them to advertising, let us say, for a period of 1 month. And this was the treatment. And now I have again data for how much they purchased in this month when they got the treatment. So by contrasting, by comparing the sales in this group in the treatment period and in the pre-treatment period, we can say we can find out the effect of the treatment. And you know very well that this will not work, because all you have to do is to go back and to session 1 when we talked about this web page design, where this company had a particular web page design on a few days, and then a new web page was introduced. And then if you looked at the sales, the web page that was introduced later seemed to be correlated with more sales, but actually it was not because of the website, the new website design. Rather, something else had happened in the after period. And in that example, what had happened was that a celebrity had come and endorsed the products that was being sold. So this is the problem by using a before and an after design. In this situation, what happens is that you cannot really separate out the effect of the treatment from the effect of seasonality or the time effect, right? So therefore, the before and the after does not work, right? Also, what doesn't work is that you do not want to create a group by taking those subjects that choose to accept the treatment and compare the outcomes in that group with another group that chooses not to accept the treatment. The problem once again over here is selection bias. And if we go back to the example that we were talking about just now, companies that have got higher brand strength, they may choose to accept the treatment, which means they will choose to advertise. And companies with a lower brand strength will choose not to advertise. And so this creates a systematic difference between the treatment group and the control group. And this systematic difference is what actually creates a bias in the coefficient of the treatment or the advertising in this case, right? So that never works. So always remember, the bottom line is that we have to randomly pick two groups, the control group and the treated group, right? And we have to measure outcomes on both of these groups at the same time, right? Now, the question is, what should be good treatments to do, right? Only when you have an idea about what treatments to do in a particular situation, only then you can design the experiment around that treatment, right? And this is where some domain knowledge or theory comes out and helps you. And that is why we'll go and look into some examples to see that how this domain knowledge and theory was used in figuring out the treatment. So the first example that I'm going to talk about is how to optimize referral incentives, right? So the idea of referrals is that a company has got an established customer base, and the company then provides this referral marketing using this established customer base, and asks these customers to reach out to their own friends and spread the message on behalf of the company, right? And this is a very established use of marketing, of messaging to customers, And companies have used it to great effect in the past few years. Take the example of Dropbox, right? It was a startup just a few years back, and then it went from zero to a huge customer base of millions of customers in just a few years. Well, the big strength was referral marketing in their case, right? So then another reason why we should care about referrals is not that it may have the ability to reach out to a large number of customers very quickly, or a large number of qualified customers very quickly. It is also possible that your established customers have experienced your product or your service, and therefore they have a good idea of who among their friends are likely to benefit from your product or service. And so when they send out referrals to their friends, they actually pick and choose. And because they have got a good knowledge about their friends and a good knowledge about your product, they're likely to pick the ones that are going to benefit a lot from your business, from your products. And what that means is that these customers are more likely to stay with the business for a longer time, and because they stay with the business for a longer time, they are going to generate higher profits or more customer lifetime value, as it is called, right? So therefore, referral marketing actually generates potentially a lot of value for businesses. Now let us go into the design of referral marketing program. So this is an email that you might have. You can get emails like this whenever a company wants to do a referral marketing program. So this is an email from Vonage, right? And you can see that the subject line of the email says, refer your friend, get 1 month of free service, right? So you can see that there is a freebie involved here if a customer goes out and refers their friend to the company. So the benefit or the incentive will accrue to the person who is making the referral in case the friend goes and signs up for the service of Vonage in this case, right? So now, if we want to design a referral marketing program for a company like Vonage, we have to first decide what treatment to give, right? In this case, the treatments are, what are the different kinds of incentives that are worth testing, right? Now, in this previous example, the incentive was given to the person who was making the referral, right? But is this the only way? Actually stop and think about that and then continue watching. So if you thought about this, you might realize that actually there are two parties in a referral situation. There is the established customer who is making the referral. So of course that is one party. And the other party is the friend of this guy who is receiving the chance to actually sign up to the company, right? So there is an inviter and there's an invitee, right? So there are two parties, and the incentive can actually be given by the company in different ways, spread out between the two parties. The company can actually give all the incentive to the inviter, as in this example, that refer your friend and get 1 month of free service for yourself, right? So the inviter gets all the incentive. But it is also possible that the company may give all the incentive to the friend of the inviter. So the invitee gets all the benefit, right? And another possibility might be that the company splits up the incentive between the inviter and the invitee, right? So you can see that there can be various ways in which this incentive can be given out. And so in designing an effective referral marketing program, we might want to figure out that which of these treatments actually causes most number of referrals to go out. Okay, so the experiment design, therefore, based on this domain knowledge and discussion, can be done in this following way. The control group consists of a set of people who never received any incentive, nor did they receive an email reminder asking them to refer their friends, right? So this was the control group. And then we had a no reward group. The no reward group was the situation when people got a reminder from the company saying that you can go ahead and invite your friends, right? But no incentive was given out, right? So you can see that the difference between the control group and the no reward group was the fact that the people in the no reward group actually got a message as a reminder, but no incentive. So that's the difference. The people in the control group got nothing, not even a reminder. Okay. Now, why this is important is that we know that sometimes people act when they get a reminder. And if the uptick in sending out referrals is high enough just by a message that costs the company nothing, then why give out incentives, right? So that is why it is important to include the no reward group in this experiment design. Moving on, we have the selfish experiment group. And as the name suggests, this is the case when the inviter gets all the incentive. In this example, this is a real case that some of my colleagues actually implemented. And so the inviter got 1,000 virtual coins. This was the incentive. In the split group, the same 1,000 virtual coins was split between the inviter and the invitee. So each of them got 500 virtual coins. So you can see that the cost of a particular referral was still the same between the selfish group and the split group. And the final group is the pro-social group. The pro-social group says that the invitee gets all the 1,000 virtual coins, right? The inviter actually gets nothing. So you might sit back and you might think that why would I send out a referral if I get nothing out of that? Well, it is true that if you don't get explicit incentive of virtual coins in this case, you may think that I'm not getting anything, but as if you think more, you will realize that if the product or the service is good, your friends will like it that you have given them a referral, and they have also benefited by signing on using that referral because they got the 1,000 virtual coins. And so there's a lot of social value in making a referral, even in such a situation, right? So now you can see we have got one control group and we have got 4 different treatment groups, right? Each treatment group got incentive of a different kind. And all of these incentives probably make sense upfront, and we do not know that which kind of incentive is actually going to generate the most number of referrals, right? Which is what we are after. So now you can see that in an A/B test, it is not necessary to have only 2 groups. You actually can have multiple treatment groups, and you can analyze all of these groups and compare them to the control group. You can also compare their performance with each other to see that which group is doing better. In this example, 380 users were selected and were randomly selected for each of these 5 groups. And the analysis of the experiment actually showed that, surprise, surprise, actually the pro-social group, which is the generous condition, beats the control in terms of the probability of sending out referrals. And the probability of sending out referrals is higher in the pro-social. The split group also does well, right? So both of these two work well in terms of the type of incentives that generate referrals. Let us now turn